You guys are getting spoiled. Oh, there we go. Did you get all that? This circle is circling the generator and the field. This is all inside the generator. Then we have the generator switch in the cockpit. When that is connected, that allows current to come from the generator, through that switch, through the voltage coil. What happens when we have current through a coil? Yep, magnetic field. It's going to pull the points closed. Very good. So this is now connected. Once it's connected, what's going to happen? Current will now flow down this way through those voltage coil contacts, through the differential voltage coil, and out to the main bus. That's just because now we have a voltage difference between where the green line starts on the left and where the green line ends on the right. There's a voltage difference, so current is flowing. What happens at the differential voltage coil, do you think? Yep, very good. Have a magnetic field. It's going to pull those contacts closed, which will then allow current to come from through the generator switch, through the main contactor coil. It's kind of like dominoes. Yeah. Okay, so far so good? All right, then we have another magnetic field, which pulls the main contactor points closed.
Oh, but then it creates a path straight from...
Yep, and this is our main path from the generator back to charge the bus.
Necessary?
Well, this was before semiconductors and diodes, and so this was all necessary to make sure current's going the right way.
What's the purpose of that coil?
The reverse current coil? I'm so glad you asked. So, right there with the red arrow, this helps the differential voltage coil to keep those bottom points closed until something happens. But normally it just helps to keep the differential voltage contacts closed. Also, you see that green line?
Yep.
Okay, once the current is going through the top yellow line, there is no voltage difference between point A and point B. True?
True.
Okay, there's no voltage difference, so this current basically stops. So these points would pop open unless we had this reverse current coil that was helping to keep these points closed.
So then if you've got another generator pushing current backwards, it'll open it.
Exactly. So if we have something, for example, the generator's not putting out enough current and the battery is higher than the generator voltage and current tries to go backwards and drain to ground, which would drain your battery, now that changes the direction of current through that coil, and that's going to allow those points to open. It's actually going to push those points open. So now the reverse current coil is, instead of aiding, it's opposing the differential voltage coil. It will force the differential voltage contacts to open. When that happens, we don't have any current going through the main contactor coil, which obviously will release that solenoid and open the contacts at the main contactor so that you don't have current draining from your battery to ground through your generator. Questions?
So would that be like a low RPM situation?
Yep, a low RPM situation where the generator's not producing enough current, or if the generator goes offline for some reason. And remember, we said it's like the RCCR and the vibrating point regulator. The RCCR did basically the same thing to keep current from going from the battery back through the generator to ground. I think we talked about those 2 points. Any other questions? Oh, that's just that's the connector, so that's showing the carbon power regulator. would be inside of there.
Oh, so what was on the last page?
Yep.
And then